Top of the morning to ya, or afternoon, or evening, I guess, whenever you're watching this. Okay, last lesson of this unit, we're going to be looking at two-column proofs. Yes, I know, proofs, they're not very fun. I don't like them either, but we're going to make them pretty simple. And then looking at some application problems. First off, looking at proofs, there's some important different properties that we need to look at. We'll make these a little bit more formal, but these are exactly what we were doing in our last unit with trying to identify the different similarity properties. But we're going to apply different things. In important properties, addition or subtraction. Comfortable that you guys have been doing that stuff for a while now. So like 2 plus 2, something x plus x. Multiplication and division, same sort of thing. We're multiplying or dividing numbers. So like 2 times 2 or 2 divided by 2, so on and so forth. Substitution. So we did this, solving equations by substitution basically means we're plugging stuff in. So like for an example, if we have like for x, or sorry, for let's go with like 2x plus 1, x is equal to negative 1. So if we're substituting, that means we would just plug in negative 1 for x. So we'd have 2 times negative 1 equal 2 times negative 1 plus 1. Heh, got you guys. And I got myself. 2 times negative 1, negative 2 plus 1 is equal to negative 1. Okay? So that's when we're plugging something. That's when we're substituting or plugging something in. The reflexive property, just basically if something equals something. So, for example, if A is equal to A. Something like that. It just means reflexive. Don't ask me quite why it's this way, but yeah. So we have the reflexive property, then the commutative property. What this is if like you have like for example, if you have like 5 times 3, that's the same as if you multiply 3 times 5. So it's basically multiplying and the order doesn't matter. Or for example, if you have A times B, that's the same thing as B times A. Hey, ABBA, Dancing Queen. Yeah, I won't sing, even though I know you guys. And so that's what the commutative property is. Transitive property, for like I put down here, if A equals B and B equals C, then A is equal to C. So let me just put that example in numbers. So if we have like x is equal to 4 and x is equal to y, so x equals 4 and x is equal to y, so then therefore y is equal to 4. Okay, then we'll keep going down here. The vertical angles property. So this is, like we've seen, that vertical angles are congruent. So if there's just one on top of the other, they're congruent. So we'll put that in here. Vertical angles are congruent. So these help us to know which angles are congruent or which angles are equal. Then with like corresponding angles, so if we see here, like we have 2 parallel lines and then we have this top angle and this bottom angle, those guys are congruent. So basically, sorry guys, so angles in the same position are congruent. And these properties are going to help us with our proofs. Okay, so those two are in the same position, so those ones are congruent. We could do an example like these two right there. The orange, what color is that? Yellow? Yeah, guess. And then we could say these two are congruent, so on and so forth. Okay, last one, alternate interior angles, so those are congruent as well. So we see these guys, so we have 2 parallel lines. If we have one there, and then the angle on the alternate side, so the opposite side of it, those ones are congruent. Okay, so we could just say alternate interior angles are congruent. Okay, then when doing proofs, so we got to ask ourselves a couple of questions. So first, what do we know? So we look at it, what do I know without even doing any math? So we'll look at that, see what we know without doing any math. Then we got to see what angles, if we can show that any angles are congruent. So if we're looking at that, hey, we see parallel lines, okay, we can say that some of these angles are congruent by corresponding angles or alternate interior angles or something like that. Then we got to look at, can I show the lengths are proportional? Once we get, so we need to set up the fractions, and then we need to name what those sides are. And then lastly, to be able to finish up the proof, we got to name what similarity theorem. Remember we had the angle similarity theorem, we had the side angle side similarity theorem, and then we had the side similarity theorem. So that's ultimately what we're trying to do. So again, nothing is different than what we did in 10.4. We're just making it a little bit more formal. Okay? So going at this, the first thing you should do, list in a 2-column proof, is the given information. So again, anything we know. Okay? So let's go ahead and look at one of these. So what's one of the things we know if we look at this? Well, we can see that they both have this little triangle here, so that means they're parallel. So we can write KL is parallel, or these two lines, that means parallel, to EF, and we know that because it's given. So this is our 2-column proof. We put our statement of what we know, or what we can prove, and then we name the reason why. Okay? So we know those two are parallel, so that could help us out. Other thing we can look at, well, if we look at from EJF, so angle EJF, that's the same angle as KJL. So we can keep along this. So EJF is congruent to angle KJL. And the reason of that is the reflexive property. Because if we scroll back up here, the reflexive property is when something equals something. So these guys are the exact same angle, so we can put that by the reflexive property, they're the same. Okay? Now if we remember, these guys are parallel. Let me go green here. Go green! Since these are parallel, that angle and that angle, those are going to be congruent. So we'd have angle LKJ is congruent to angle FEJ, and that is by the corresponding angles. Because again, if we scroll back up here, corresponding angles that are in the same position, those two angles are in the same position. Okay? Alright, well now we know that one angle's the same, two angles the same. So if we know that two angles the same from our angle property similarity, we know that these are the same. So we could say triangle LKJ is similar, the squiggle, to triangle FEJ, And that's by the angle similarity. Okay? Alright guys, so I'm gonna see if you guys leave these to you to solve these two proofs. I'll go ahead and fill these out and look at the example. Hint on this one, look for at your proportions. And the same here, look at your proportions. See if you can figure those guys out. Okay, I'll post these answers on my notes, that way on my website, that way you guys can figure them out.